this lecture, we are going to understand about how electric current can produce magnetism. Well, when electric current passes through a wire, the electric current carrying wire behaves like a magnet. This is called the magnetic effect of current. The magnetic effect of current is used to make a large number of devices which we use in our daily lives. For example, the magnetic effect of current is utilized in making electromagnets, electric bells, telephone instruments, electric fans, electric motors, loudspeakers, and toys, to name a few. The magnetic effect of current was discovered by a scientist named Hans Christian Oysters. Oysters found that when electric current was passed in a wire, then the needle of a compass placed near it got deflected from its usual north-south position. Now, the needle of a compass is itself a tiny magnet which can rotate freely on a pivot. A compass needle can be deflected only by another magnet's magnetic field. Since a current-carrying wire was able to deflect a compass needle, it was concluded that the electric current flowing in a wire gives rise to magnetic field around it. Let us now describe Oysters Experiment, which Hans Christian Oysters did in 1820 in detail to understand the magnetic effect of current more clearly. Let us take a thick insulated copper wire and fix it in such a way that the portion AB of the wire is in the north-south direction as shown in the figure on the screen. A plotting compass M is placed under the wire AB. The two ends of the wire are connected by a battery through a switch. When no current is flowing in the wire, the compass needle is parallel to the wire AB and points in the usual north-south direction. Now let us pass electric current through the wire by pressing the switch. On passing the current, we find that compass needle is deflected from its north-south position as shown in the figure B. And when the current is switched off, the compass needle turns to its original position. Now we know that a freely pivoted compass needle always sets itself in the north-south direction. It deflects from its usual north-south direction only when it is acted upon by another magnetic field. So, the deflection of compass needle by the current-carrying wire in the above experiment that we have discussed shows that an electric current produces a magnetic field around it. Let us explain whatever observation we had. The observations of the experiment conducted by Oysters suggests that a current-carrying wire produces a magnetic field around it, and the magnetic needle of compass experiences a torque in this magnetic field. So, it deflects to align itself in the direction of magnetic field at that point. On increasing the current in the wire, the strength of the magnetic field around it increases. And this is shown by the increased deflection of the magnetic needle. On reversing the direction of the current in the wire, the direction of magnetic field reverses, so the direction of deflection of magnetic needle of a compass is also reversed. So what are our inferences? The inference from this Oysters experiment is a current or moving charge produces a magnetic field around it. This is called the magnetic effect of current. The strength and direction of magnetic field depends on the magnitude and direction of current.